For someone who wants to look at this space, is have to put yourself in that future vision and explore what ideas may surprise you.
Hey, Karl, how's it going?
Good, Erum. It's good to be home again. I think last time we recorded, I was in California at my parents' house, and I'm back in New York City, and I'm happy to be here. What's going on with you?
Oh, well, home for the holidays and not Christmas holidays. There's been back-to-back holidays. It was Halloween, Diwali, and then Dia de los Muertos back-to-back.
And today's election day.
And then today's election. It just isn't stopping. It's great. And that's this time of year. Our social calendars are booked. We have a lot to look forward to, but we have jobs too. So it's balancing work events, which a lot of work events are holiday themed, and then you have social events with your family and friends, and then daily life. And then I'm trying to carve out some alone time because I just feel that my social battery is completely drained. So I'm looking forward to the weekend. I carved out a whole day where I'm like, no one talk to me. Let me just reflect on all the conversations that I've had and be grateful for where I am. And that's before Thanksgiving. Thanksgiving will be a whole level of gratitude that I'll bring to the table. but yeah, it's been a wild ride.
Yeah, well, I hope it's okay for me to say this, but for our listeners, it is going to be Erum's birthday by the time we record our next episode. So you need to take some time off. I think it's a good idea.
Yes.
We do have a policy at Messaging Lab that you do get your birthday off. So when your birthday is on Sunday, have a good time.
Thanks. Thanks a lot.
No, you know what I mean. And
yes.
Hopefully our listeners know I'm kidding. Okay, so it's been wild on the social event side of the world, but there's been some really great news and some great pop culture stuff that has to do with biotech. You put Wild Robot on the list. Why did you do that? What does that have to do with our podcast about growing everything?
Well, anything I experience or see these days, I bring back to biology. Like I look at it and I'm like, wow, I got to talk about this on the podcast. So if our listeners have seen or heard of this new movie called Wild Robot, now it's streaming. My 3-year-old son just ordered it, so we were watching it.
Fun.
But Wild Robot is a very interesting, heartfelt movie about a robot that crashes into an island, and the robot's programmed to serve and complete tasks and just be very helpful. And this movie is set in the future. But on this island, there's just animals. There's no humans. So the robot's trying to help animals. Animals are like, what is this thing? And the wild robot ends up learning the language of animals, starts learning that these animals are programmed. So what's a programming of nature? How do foxes work? How do goslings work? How do bears work? So the robot's observing and learning. And there's this incident where the robot comes across this egg and it hatches a gosling duck. And all of a sudden, this robot is tasked to take care of this little gosling and tries to learn about it and ends up starting to feel like what it's like to be a mother and the challenges of being a mother. And you don't have a playbook to be a mom once a baby arrives in your world and you're trying to do things and it's not working. And for me personally, obviously it was pulling on the heartstrings because I'm a mom. You're a parent. So you could, if you watch it, I'm sure it will pull on your heartstrings. But it was this great commentary on like, okay, biology is programmed. So this robot programmed with AI, I'm sure, is trying to learn, observe, and understand nature. And it starts to understand. But then at the same time, it becomes reprogrammed because it starts feeling love and understanding, okay, there's this idea of family and reprioritizing not just you, not just tasks, but the well-being of others. And I thought it was a very interesting social commentary of the world we live in today when we're trying to balance nature and technology. So I highly recommend it. It's heartfelt.
Well, I don't know if I mentioned it. I love animation a lot. And I had previously, I think, mentioned Scavenger's Reign, which is an animated show that's on Netflix, which is really wild in that it shows this planet that is biology and how unimportant humanity is on that planet. And what's interesting about this, what you just said about Wild Robot, is thinking about how AI will learn from nature, which is where people are creating training sets based on biology. But when AI is tasked with protecting a forest or protecting different parts of nature, how will it interact with us humans and how will we have to learn to deal with that? But I watched something that's the opposite of Wild Robot. You watched a heartfelt child movie, and I went and I saw The Substance, which is much more of a social commentary horror film, body horror, which is about an aging celebrity taking a black market drug. So there's the biotech, a substance that creates a younger, better version of her. And there's a lot of question marks in terms of how can this fully formed adult be born of this fully formed adult? But that is one of the devices of the movie. But then there's another device in that each of these two entities can't exist simultaneously. One, they have to balance each other. So the younger one starts to take advantage of her time and starts sucking the life out of the older one, which in turn affects her. It's a wild ride, is all I can say. I'd been warned that the ending was crazy, and the ending was pretty crazy. And there's all sorts of references to classic horror movies. There's Eraserhead, there's The Elephant Man. It's a wild movie. And it does have this biotech element to it. But if you're into body horror and you don't mind gore, then you would enjoy it. Otherwise, I'm not sure I would recommend it because it is pretty gory and sometimes very uncomfortable.
I would just watch it because I love Demi Moore. And I love the fact that she put herself out there in this film where it sounds avant-garde, I guess. It's something that you don't usually see. It doesn't follow maybe the traditional storylines, except for you made a nod to some of these old horror films. But still, you know me, I prefer watching the heartwarming stuff versus the scary, gory stuff. It's not the frame of mind that I like to be in, but art is art. So maybe I'll take some time to watch it as far as I can go.
Yeah, I mean, all I'll say is she was great in it. And then the woman who plays her younger version is also great in it. But there are parts of it that are very much over the top. But let's talk about some science news before we get into the podcast. So this past week, Time magazine did their 100 best inventions of the years. And biotech featured very prominently. It was even on the cover. Glowing plants, light bios, glowing petunias were on the cover. You've seen them, right, Erum?
Oh, yes. I've seen them. I know a lot of people that have ordered them. We mentioned them on the pod before. That's cool. That's great to see that they had biotech and biology and bioluminescence on the cover of Time. I love that.
Yeah, there was a whole long list of things that were either biotech or medical related. The other ones that I noted were Inner Plant is a company that has something called Crop Voice, where they're basically engineering crops to serve as sentinels. So they basically can emit an early warning signal about their health, which is really wild. And I've mentioned this Japanese science fiction book about biotech Gene Mapper in the past. What they're doing has very much that kind of vibe, the ability to monitor crops from satellites and have the crops tell you what they need themselves is so science fiction-y, and these guys are doing it right now.
We had Ari Wright on the podcast from Bison Ventures, and they invested in Interplant. So she talked about them a little bit on the podcast. So guys, we're scooping things on this podcast. We talk about things, then they appear on Time magazine. So you guys are very fortunate to be listening to this podcast. You guys are on the cutting edge. So you're welcome.
For sure. So the other one that we've mentioned on the podcast, and actually we just had the chief strategy officer on, Dan Grushkin, was Tomtex, who makes biotextiles from, I say, shrimp waste, crab waste, from basically waste chitin that comes off the shells of different sea animals. And then our friend Ray Cutland, who works for the Rootist Root Biomic Ferment was also mentioned as a great product because it strengthens your hair. I'm a fan of their shampoo and their conditioners because it's highly concentrated. I have not really used the ferment, but I have it in my medicine closet. I have to get to it before it goes bad.
Yeah, I also got some samples of that, or actually they were full-blown products. That's what happens when you have friends that are formulating, and it was great. I need to get some more. Sometimes you use products that actually makes you feel better. It was such a really cool product. And it's interesting because there's two different layers of fluid. One fluid is more dense than the other. So they shake it up in order to use the ferment. But I see why Time Magazine recognized the Root Biomic Ferment as an invention of the year. I have not even wrote to Ray and congratulated her. So that's on me. And she'll get this message. I'm going to do it right now.
Okay. So, another thing that was in the news that was not in the Time 100 was this Japanese company, Lignosat, launched a wooden satellite. And when they show that picture, it looks like this little tiny box. I think it's more like the size of a small fan. And these guys at Lignosat, they have a 50-year plan to grow trees on the moon. And I just love that they have a 50-year plan. It's a very, to me, take this how you will, it's a very non-Western idea to have a 50-year plan. So the Japanese also have a plan to build a space elevator starting in the 2030s, which I'm a huge fan of. And the fact that these guys want to grow trees on the moon, I'm all into that. I can't wait to see how they progress.
Wow. Wow. We can do a whole episode on this. We have to get the Lignosat leadership or someone on their team to come on the podcast and talk about this more because there's so many questions. What's the plan to grow trees? Are they going to put some microbes in the regolith in order to feed or have that type of symbiotic relationship that trees are used to and need in order to grow? What's the plan there? Or is it going to be in a dome somewhere? I would love to learn more. And you said 50-year plans are not really considered in Western culture, but I will give one shout out to a Western writer, Chris Mason, who has a 500-year plan.
Okay, sorry. Yes. We need to get it. We've mentioned him many times on this podcast and we need to get him on. I want to know how he did. He ran the New York City Marathon this weekend. I want to know how he's doing.
Yeah. So this is so cool. A wooden satellite. My mind is also going to, how is this dangerous? What's the protocol? What's the rules in bringing biology to the moon? I mean, obviously, who's going to create the rules?
Yeah.
You're going to the moon. Yeah, we went there. I don't know if we left any microbes on the moon. I don't think so because all the astronauts were in spacesuits, but they had to put the spacesuits on. And so there could have been microbes outside. Because we want to know, are there microbes on the moon somewhere already? I don't know. I'm digressing because I'm just so excited about this piece of news. There's just so many ways to think about how this is innovative, how this can help with other moon missions. I'm thinking of our astronaut friend, Dr. Kate Rubins, who we had on the podcast. What does she think about this? Would she like to see trees on the moon? She talked about setting up a moon base because that is part of NASA's plan to do that with the Artemis mission. So what's the plan there? How are they collaborating? So yeah, we can go on about that.
Yeah. Now I'm going to blow your mind for a second before we get into the episode. But one of our friends who we'll be talking to in a couple of weeks, she introduced me to this author, Peter Hamilton. And I started reading this huge book. It's the first of a trilogy. It's 1,200 words called The Reality Dysfunction. It's a classic space opera that takes place in the 2600s. But what's super interesting about it is they're flying around in living spaceships. And these spaceships can go warp speed, so faster than the speed of light. They can go through wormholes. The captains are biologically enhanced so they can communicate with the ships. So there's all sorts of crazy stuff in this book. It probably merits its own episode, but let's not go down that rabbit hole. Let's get into our episode.
Yes. Wow. I mean, we'll get into it at some point. We'll talk offline about this, and I need to read it too. And hopefully there's a movie coming out, but sometimes a movie's not as good as a book.
Yeah.
But anyway, I'm really excited about this episode because it's really dear to my heart. Today we're interviewing Moji Karimi of SemVita. And SemVita is converting carbon emissions into valuable products. This is a world that I lived in over 10 years ago. I met some young, brilliant PhD students in India, and they were working on creating a reactor to convert carbon emissions into carbon nanotubes. And that was very early on.
I remember that's when I first met you.
Yeah. And now here we go. A decade later, there's companies like SemVita that are taking to the next level, not creating advanced nanomaterials, but creating very useful products. And our guest today, Moji, will talk to you more about it. But it's really cool to have someone like him on the podcast because he's an entrepreneur. He has a background in petroleum engineering, and he's bringing his ideas using biology to create a new regenerative, sustainable way of producing products. And fun fact, it's with his sister who has an advanced degree in biology. And it's an incredible story. I'm so excited for our listeners to hear the story of SemVita with Moji Karimi.
Let's let Moji take it away.
Moji Karimi, we are so happy to have you on the Grow Everything podcast. Thank you for joining us today.
Absolutely. I've been excited about this. Thanks for the invite.
Yeah, of course. I've been thinking about SemVita for some time and the work that you guys do. And I wanted to learn more about the person behind all of this, the person, the team, because I know it takes a large village. But yeah, you have a very impressive background, but so does your sister. So you and your sister co-founded SemVita, but what inspired both of you to start this company? And how did your background in petroleum engineering and her background in biotechnology converge to create this venture?
Sure. And actually, that is the essence of SemVita. And for SemVita to exist, trying to do what we do could not have happened any other way. So my background started off in the energy industry, but I've always been passionate about multidisciplinary sciences and just innovation in general. And I realized that in my own career, it started in R&D, but I kept asking questions about what is the business model, what's the big picture, and grew in that direction throughout time. Eventually, I got more interested in the startups. And the company that I was so lucky to join was a company that wanted to commercialize DNA sequencing in the subsurface, looking at DNA of microbes in the oil and water and rock and building this kind of a 23andMe type maps for the subsurface. And our main investor was Illumina. And that's how, as a petroleum engineer, that was my introduction to biotech. Once I got into that, I realized this whole world of possibilities, DNA sequencing just being a tool, but the bigger tool set being bioengineering. Again, I was lucky that around that time, kind of 2012, 13, Tara just so happened that she moved to Houston. Tara's background is all the way biochemistry and synthetic biology. She's 2 PhDs, 2 postdocs in the field. When she moved to Houston, she was doing a tissue engineering project with MD Anderson and Texas Heart Institute. So we've never imagined that our worlds would have an overlap because I'm going to drilling rigs. She's going to like hospitals in lab coats and stuff. But the DNA sequencing part of what I was doing became the linkage where I shared with her, this is what I'm doing. And she's told me about DNA sequencing in more depth. And that became the start of longer organic conversations where we both arrived at the conclusion that there's a lot of potential in biotech and bioengineering, and there's a lot of problems to solve in the energy industry and heavy industries in general. So who is going to do that? Who's going to do this translation and find what are the applications that make sense and know how to pitch it to the traditional industries? So that's what we've set to do. At the beginning, we did not know what those applications are. Typically, the advice is find the problem and then go and become an expert in that and find the solution. We're just so excited about industry biotech that we said, let's start. We'll figure out what the applications are. And that's what happened across the past 7 years.
One of the things that your technology does, and you'll tell us, is it synthetic biology? Is it biotech? But one of the things that it does is it transforms carbon dioxide emissions into valuable chemicals. Can you tell us how that process maybe differs from traditional carbon capture and storage? And was that what you guys set out to do at the beginning of SemVita?
Yeah, at the very beginning, we started with CO2 utilization. Actually, at the beginning, we also were using a photosynthetic pathway to avoid having to use hydrogen, which is a bigger challenge for CO2 utilization in general, and using light as a source. Initially, because the cost drivers that we see today, they were not here as far as the interest in low carbon molecules. So we found an application actually in aerospace for using the CO2 that astronauts breathe out and converting that through our bioreactor into glucose as a source of calories. So it was a closed life support system, if you could call it. We had 1 or 2 projects that we got support for, and that was the beginning. But then as we built the platform, we moved in the direction of energy transition. And this coincided with 2018, 19, 20, where this wave came through, where companies became more and more interested in investing in CO2 utilization or higher volume, lower value, you could say, more of an intermediate commodity type applications. The way that is different is that we believe that CO2 should be used as a feedstock as opposed to only be viewed as this waste that will have to be sequestered. Part of the reason for that is if you think long term, you have to spend money to sequester the CO2. So you see companies doing that today. A lot of that is underpinned by 45Q in the US. So if it's from initial source capture, you get $85. If it's by direct air capture, you get $180. And that sunsets in about 12 years. And so beyond that, what is the incentive for these big companies to keep doing that? Whereas if you could use CO2 as part of a process and deliver some sort of value on the back end and create revenue and fine tune the process, now you've given the industry something that they're going to keep doing more of on their own without needing to rely on government. So that's the policy part of this. And then the other part of it is, if you look at nature, CO2 is used in many processes. So when are we as humans going to learn from that and be able to engineer solutions at a scale that could do the same thing to solve the issue that we have with CO2 on one hand, on the other hand, create more of a low carbon molecules for everything that we need and fuels as well.
Yeah. You mentioned your project in the aerospace with astronauts, CO2 and making that into glucose. And that piques my interest because I love space. I just love thinking about it. So very, very cool. But you also mentioned some other applications. And we talked about this before we started recording about different applications in energy mining and aerospace. And this is a challenge that a lot of companies have been facing in the space, where some are looking at becoming a platform versus creating products. And I know that you guys have been navigating this very well, but of course there's challenges. Can you talk a little bit to this? Because I think whatever you're going to say could be a great clip to share with all of these other entrepreneurs who struggle at this intersection of platform versus product.
Yeah, then honestly, that's been the most fun part for me of the past 7 years, is navigating around this exact thing. When we started, the vision that we had was industrial biotech for energy transition. It was very broad, both on the industrial biotech side of it, and then on the energy transition is also very broad. Our thesis was that there are applications where it makes sense and it's economical to deploy new solutions today. We found 3 of those applications. One was for subsurface biomanufacturing of natural hydrogen. Basically, I mentioned that early on, I was studying DNA of microbes in the subsurface, and I'm a petroleum engineer. In the oil and gas industry, there's a lot of legacy for microbiology, but most of it is focused around sulfate-reducing bacteria that produce H2S. And H2S is bad news because it sours the reservoir, it corrodes the pipes. So there is a huge body of work in the oil and gas industry in using biocides to kill SRBs, but through that, they have microbiologists working for these companies, but they're all just trying to kill the microbes. So we asked the question, and Tara asked the question, are there good microbes that we could use? And how do we try to solve this problem with optimize for biology as opposed to just trying to use chemicals the industry has been doing with biocides? So one of those applications became, can we in situ produce hydrogen in the subsurface and use the reservoir, the porous space in the reservoir as the bioreactor? So we continued to develop that solution into a full package. We tested it in the Permian Basin, and eventually we're getting deeper and deeper into the vertical for the subsurface while we're trying to build a platform, which is a matrix. Just put a pin on that. This is one part of the story. The other application we found was in the mining industry. This one is easier to think about because I realized that about 15% of the world copper today is produced with microbes. And this was a big surprise to me in a process called bioleaching, where they remove the copper ore and they stack them up in a heap leach. You could traditionally use something like sulfuric acid to leach out the copper, but you could also use microbes that do about the same thing, and that's bioleaching. So big companies like BHP and Rio and others, they've been doing this for about 50 years. But the way that they've done it is being more what is called like a bucket microbiology, where there's a culture, they isolate and they pass on between the different assets. And the question was, okay, well, we have a lot more tools now. Who is going to really upgrade this process to much better understanding of the performance of the microbe, the consortia, to continue to maintain the recovery? So that became that core application. And that also quickly started to go deep into the mining vertical. So we had that second application. And the third one was the one we already talked about, using carbon streams for biomanufacturing of low carbon chemicals. So we had these 3 applications. All 3, the markets, they're not mature for using biotech. So let's say if you're Ginkgo, you could engineer a microbe and just give it to Pfizer. And they say, oh, thank you very much. We take it from here. They know what to do with it because they have the same capability, but mining industry doesn't. Oil and gas industry doesn't. Chemical industry doesn't. So what happens is they will pull you in to have to also scale and develop the application. And that's where the challenge happens, because you have to decide, are you going to stay at the top, closer to the platform, or are you going to get pulled down to developing the product? And you can't do both. One of our board members says this, like, people love platforms once they're done. Once they're built, they're amazing. But the process of making them is extremely challenging. Running a matrix organization, allowing for sharing of the resources between different applications, where the applications start to have different needs, different type of analytical testing that is required, starts to become really expensive. At the same time, we had this other issue, which was very interesting. Say for our Series A and Series B, we had investors who would say, love the mining application, not into hydrogen. Love the CO2 use case, not into mining. So can I just invest in that? And before, it's like, well, this is a full package. You just have to buy into the big vision. And we did pull that off, actually, for our Series A, to some degree for our Series B. But as those companies were becoming more mature, we realized really the better pathway is to unleash the mining and oil and gas applications so that they could develop their team, raise money from specific investors to that industry so they could run far. And so we made the decision to spin out those two companies. And today they have their own CEO, they have their own P&L and board members, investors, and everything. And so that left us with SemVita and the use case for carbon waste to sustainable oil application.
Wow, that is amazing. You mentioned a lot of things, but one of the things that I took away from it is you pioneered biomanufacturing using natural hydrogen and other subsurface applications. What opportunities are you seeing in the space, and how has the spinning off of those two verticals helped you focus on that?
Yeah, so the big picture was we believed in situ biomanufacturing, in saying that a lot of the legacy of what we have done to date has been based on doing things inside the bioreactor that we built on surface, whereas in reality, a lot of these reactions are already happening in nature, outcome of which we're enjoying, whether if it's oil and gas that we're extracting or minerals and metals that through the use of microbes have been liberated. It's a different way of thinking. It's environmental microbiology meets in situ biotech, and then you could get into the synbio part of this, even if it's more like a adaptive evolution or directed evolution as opposed to like hardcore GMO. So in those two industries, we found these use cases, one of which in mining, it was already done. So it was more about, can you use this microbe instead of that one? Or can you use these tools to monitor what is already being done? And honestly, I just think about people who first did this, they're the true innovators. And it's so odd that we've done the actual big innovation, but now some companies could be resistant to making improvements to the same thing that they have pioneered. It's a weird thing. I call it the pioneers paradox. The pioneers suffer from the same issue because they were pioneers on the mining side. And the oil and gas side, the same way, the thinking was, why are we going and extracting this natural resource of hydrocarbons? And then what these companies are doing, they plug and abandon that reservoir and move on to the next one. But you've done all this work to get access to the subsurface. And when they leave, they still have 10, 20, sometimes 50% of the original oil that is unrecovered. So we said, could we think of this as a natural subsurface feedstock instead of hydrocarbons? And could we envision a future where you could have underground biorefineries, where you could integrate downstream with upstream? Because if you think about today, the product doesn't change. The whole oil and gas industry is about finding where the oil is, drilling to get to it, and then bring it out. And then pipelines send it to petrochemical downstream. Say, okay, now you guys turn this into useful things. But now we have this understanding that maybe we could go to the source in the subsurface and actually convert the oil and gas into other things that we need. Hydrogen is an example with the work that we did with gold hydrogen. So that requires a much deeper understanding of environmental microbiology and in what ways can we actually control that and scale it. These two were the applications that we developed. We did come across many other applications as well in different industries. Actually, we did this study through a foresight framework, which is what futurists use to envision what those applications are. Anything from self-healing concrete to very efficient microbial fuel cells to biological data storage and computing. There's different examples that we could learn from nature. This is really Tara's strength, is biomimicry. Is looking at the natural system and trying to re-engineer it in ways that they could scale it into a commercial application. My job then is like, well, how do we make money from that? And what's the business model? How do we explain it? And that's why this has worked so well with the two of us working together closely. But the focus part came in because it was like running three companies at the same time. And it's very challenging. They have different development stages. The industries, the three of them moved at different speed. Investor profile was different. And even though I could share this, I was hopeful that we'll come across investors that saw the big vision to say, we want to see you through this. Let's go and develop this. And we'll support to have a bigger network or support system to be able to do it. At the end, it's tough. So we decided to spinning the two out is a better path, though SemVita maintains equity ownership in the two different amounts. We're very happy with that and continue to support those companies. We call them, it's like our children who has grown up and now they've gone to college and they have now their own apartment and offices and stuff. So I'm happy for them. And I work closely with Liz and Endolith Prop on gold hydrogen side. And in the future, we could even collaborate together, even do business together.
Yeah, I think it's super interesting what you say about the people. Let's just talk about the copper leaching using microbes. And I've probably said this on the podcast before. We've had Alonia on. Alonia does environmental remediation. And we had looked at what's the innovations in the mining industry. And there's like reports out there that I ended up reading. And biomanufacturing or biotech was not a part of those reports, which I was really surprised by. And maybe at this point, those reports are dated a few years. So hearing you say you had very specific investors who were interested, but the end customer is still unsure because they have a process in place, even though you could make it potentially 10x, 100x, 1000x more efficient and localize it. I find that to be super interesting.
It is. And it's as much of a technical conversation as cultural. The big companies, sometimes they're not structured to incentivize motivation or people taking risk, which is something we already know. But I think the breakthrough comes from when you have people who work, say, in the oil and gas industry. They go learn about biotech and companies that are doing this that are based in, say, Houston or places where there are the hubs, and this merger that happens. Because it's going to take some time to educate, to get up to speed. And we've seen this in real time. In the work that we do, for example, with Oxy is our biggest investor to date, and we work with them very closely. I mean, these are some of the smartest chemical engineers in the world. So we started working together. And we know when it's going to be a good relationship where no one says, oh, well, this is over my head. I don't know about biotech. They just ask first principle based questions. They just keep asking to go deeper because at the end, it's all chemistry and try to understand it from the bottom up. The relationship started that way. And then they said, hey, Tara, can you do a course for us for Synthetic Biology 101? And Tara did that about 4 or 5 years ago. And today, if you go to a meeting that we have with Oxy, their engineers are asking about, well, what plasmid are we using here? They could read a lot of the analytical testing, the data, and they love it because it's a whole new world. What they told us, their chief process engineer is like, once I understood that inside the cell is like a chemical plant, the light bulb went off, like the pathways and the possibilities. And they're so amazed by manufacturing and the microbial capability to be very precise because they're used to, if you use ethane to make ethylene, you're also going to get propane. You're also going to get all this, which is why they have all these fractionation columns. And it's something that they're very used to. Same with the high pressure, high temperature operations. It's been great to create this new way of communication. And I think to your point, once more and more of this happens is where in the reports like that, it would inherently include biotech, not as something weird that maybe we could use, but as something that is already part of the solution.
Yeah, that's, again, very incredible. So I want to go back to this idea of spinning out. SemVita has positioned itself to be a startup for startups. So now there's the different business lines. You mentioned gold H2 or gold hydrogen and Endolith. These are spinning out their own. They graduated from SemVita and live on their own. So do you see more spin-outs happening? And these are run by different CEOs, of course. Is this a model that will happen? Because again, you mentioned several applications. I'm curious to hear your thoughts on more startups.
No, it's a great question. And the answer is that we do not intend to do that. We did that so that we could focus on commercializing our core application. Now, once we do that, a few years down the road, we have operational plans and making revenue. I do have a vision along with Tara to create what we call almost like a future labs, where we think about other problems in the industry that maybe one way for bringing those to life would be through a spin-out type or a JVs or different type of collaboration. And now we have a bit of experience doing that. But for a company to try to do this as their core business model, it would require different kind of investors, because now you're telling investors that invest in us because we're going to spin out other startups as opposed to the core application. And it would change you from an actual biotech company that is going to solve the problem into more of a incubator type system. So it could be done, but it's a different business model. And right now we're doing engineering work for our first commercial plants, fundraising for that, and everything is geared towards that. The other thing is when we went from platform to product, we have to redo our org chart, because before we had capabilities end-to-end like bioprospecting, analytical services, fermentation, synthetic biology, techno-economic assessment, all of those things, and they were servicing 3 business units. When we did a spin out, we made some decisions in terms of, okay, maybe this person makes more sense to go to Gold H2 or to Endolith. And then we had to decide, okay, does SemVita still need bioprospecting? Because that was more of a need for those two who are like environmental as opposed to what we do. Because of that, I ended up calling SemVita 2.0, which was our version of the rebirth. So that doesn't have the same platform capabilities. It's more focused around the core application.
Hi, a quick shout out to our sponsor, Messaging Lab, the force multiplier for biotech. Your biotech company is making the world a better place. You know that, we know that. But does the world? There's a big reason why some biotech companies attract investors, sign up customers, and get attention. That reason is strategic communications. At Messaging Lab, we translate complex science and economics into compelling narratives. And we have done that for the most successful biotech companies across healthcare, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice, visit messaginglab.com to explore how we can elevate your story and grow your business.
Now, you talked about your relationship with Oxy being one of your biggest partners, and this is with SemVita. And then you also have an alliance with United Airlines. What are the strategies that you use to build those relationships, and how do you sustain them going forward?
Yeah, I mean, there has to be synergies with their mission. In the case of Oxy, there's a lot of focus on CO2, and they built in this big direct air capture plant in Permian Basin, plan to build a lot more. A lot of that is to be sequestered, and they do have some EOR operations, but they still very much believe in CO2 conversion as a category. So through Oxy Low Carbon Ventures, they've made investments in SemVita, a few other companies to help develop those pathways that could convert CO2 into valuable products. So that's the body of work that we do with them. One thing that sometimes people don't know about Oxy is that when people think Oxy, they think Permian Basin, oil and gas, drilling, but they also have OxyChem, which is a downstream part of Oxy. It's a chemical company, basically. And a lot of the people that we work with actually are in OxyChem. So they have the capabilities. A lot of Oxy is the number one producer of VCM in North America, which is what is used to make PVC. That was a surprise when we learned about that. So CO2 conversion. When it comes to United, it's quite different. That one is about sustainable aviation fuel. I'm sure you guys have covered at length. If you look at what is going on with SAF, the number one way about 95% of SAF that's produced today is through this HEFA process, hydrotreated esters and fatty acids. So HEFA process uses vegetable oils, animal fat, and used cooking oil as a feedstock. And if you look at projections for all those 3 things combined, it's flat from here, because you can't envision ways that out of a sudden we're just going to have a lot more animal fat or used cooking oil. And there's a lot more demand on those feedstocks. At the same time, there's a lot more need for SAF, and companies have committed and projections by 2030, by 2040, in Europe is even more aggressive. So what they did was, okay, if we need more SAF, HEFA is the main way to make it. What is holding HEFA back? Availability of feedstock. What does SemVita make? This oil profile that we could make from carbon waste. And this oil profile is very similar to vegetable oils that could be used in the HEFA process. So we basically create this drop-in for the HEFA process that helps ease some of the pain for availability of the feedstock. So that's why they invested in SemVita. That's why they did the offtake with us. Eventually, there is a pathway to also go from CO2 to the same oil, which is a way to make it even lower carbon. But we're not limited by that. We found other carbon waste streams to be able to fast track the process and produce oil within the next few years. but that's what we're planning with our first commercial plant.
Can you remind me what a HEPA process is? What does HEPA stand for?
It's a hydrotreated esters and fatty acids.
Oh.
Hydrotreating for the most part. It's a process that vegetable oil and other, fats and greases goes in, and then SAF basically comes out. There's more blending that happens on the back end, but it's primarily the way to make SAF. Outside of that, there is e-fuels through a lot of companies in that space, through electrochemistry.
Mm-hmm.
Yeah.
And just for our readers who don't know, SAF is sustainable aviation fuels.
Yeah. Because if you think about the challenge that aviation industry has for decarbonization, unlike you could drive a Tesla instead of your normal car, but we're years out from being able to reliably fly electric planes long distance or hydrogen planes. So the way for them to decarbonize is to decarbonize the fuel and be able to use the same airplanes with the same engines.
Yeah. And you mentioned decarbonization, and that seems to be one of the big themes for SemVita, decarbonizing and transforming heavy industries. So how do you think about navigating the balance between, you guys are very innovative, these companies have existing infrastructures. What kind of strategies do you guys have to use to persuade these traditional legacy big industries to adopt these biotech solutions?
So there's a few things. I would say, though, honestly, if I've learned one thing is that it's not about convincing. It has to make sense to them. And the number one way of making sure it makes sense to them is if you could have cost parity to what they're doing. So you make the sustainability part more of a bonus in the equation as opposed to demanding large premiums. That's where convincing comes in and persuading, which is challenging. But as part of that, we've also become more targeted. Before, when I had more of a convincing approach, we talked to everybody and we try to convince them. And it was like self-inflicting pain. And you're like, why don't they get it? Why don't they want to be sustainable? But in reality, there is only 2 to 5% of companies who truly are thinking about the future beyond the next quarter or whatnot, who truly thinking about technology breakthroughs and have the right structure, right champions inside the organization to help. So most of the time, it's just like finding to make sure we're spending time in that 5% category instead of trying to hope that's 20%, because it's not something that I control. The other thing that I found is helpful, and this is truly what we believe, is that it's not just about decarbonization. As a matter of fact, that's one of the problems, because right now everything is so indexed on CO2 emissions that sometimes that comes at the penalty of the environment in ways that it's not measured. This same SAF thing is an example. Who is to say if you cut down trees in the Amazon to plant soybean farms and then squeeze the oil out to make SAF is a better way than just using hydrocarbons? One creates emissions, the other one has impact on nature and its biodiversity, its water use, its land use, its fertilizer use. So historically, a lot of times the view has been, if it's not oil and gas, it must be great. And now we're realizing that everything has good and bad. Same with mining, electrification, batteries, they take cobalt, they take lithium, all of that. So today, we don't have a framework that allows us to compare these holistically when we compare solution A versus B. And I've asked a lot of smart people, and they just say, look, man, this is complex. We have this carbon thing we could measure. Let's just focus on that. But it's nagging in my brain because I know that it's not right if we just do it based on carbon. What I'm hoping is that we have COP30 coming up in Brazil. It's going to have a huge focus on biodiversity. So I'm hoping that by then we'll have more frameworks that helps companies make more informed decisions and us as people make better decisions when it comes to decarbonization as opposed to protecting nature. And this is exactly where I think biotech could have a lot to say. Honestly, when these companies are today doing what they call nature-based solutions, and a lot of it is planting trees and things like that. You know what's an elegant nature-based solution is bioleaching. It's subsurface biorefineries, is learning from nature and re-engineering and scaling that. And there's more opportunities to do it that way, which I hope that companies go in that direction.
Yeah. So for the COP30, the climate change conference in Brazil, I think is brilliant. I mean, it's definitely a statement saying, let's ensure that we have biodiversity as part of this conversation. And I've been to a few biodiversity summits, and there's an effort to put a price on biodiversity, just as there's a price on carbon. And I don't want this to be a conversation about carbon credits, but we're starting to learn more. And like you're saying, we don't need to have a monoculturing to be a solution, because that's actually really bad. Especially when we think about this podcast is about biology, the beauty of biology, the diversity of biology, and how can we learn, not extract or exploit or manipulate the very, very harsh terms, but to honor and to learn from and to mimic. I think that's something that I'm glad you guys are thinking about and also taking into consideration as you grow your company. Very, very good. I also wanted to think about the space overall. We've had a few companies on this podcast that are converting carbon emissions into products. So a company called Solar Foods making proteins from carbon, obviously Lanzatech making a whole bunch of things, platform product, whatever you want to call it. They're going to different industries as well. So my question to you is, when you're talking about carbon conversion into products, how are you differentiating it? Is it in the microbe section of it? Is it saying, hey, look, we need all solutions all at once? It could be similar as another company, but we're doing it because we need these solutions. I'd love to know a little bit more about how you look at SemVita fitting into the ecosystem of carbon capture and utilization, or converting carbon emissions.
Mm-hmm. Yeah, absolutely. So there are four specific things. Number one is that we use carbon waste as a feedstock. That's different in this space that we're in, because we convert it into an oil profile, because we found that to be a very versatile platform. You mentioned Lanzatech. For them, that's ethanol, for example. For us, is this oil profile. And we use carbon waste to make it. And there's companies in that space like Amyris, like Solazyme, others that have used sugar. And sugar, of course, you could do it, but it becomes a cost issue, and some of the environmental penalties that comes with sugar also cannot be understated. Yes. So we specialize in finding carbon waste streams, and this could be from different industries, from the same biofuel industry, from agriculture, from food. Now I get into the second part. The differentiation is the optimization engineering that we've done on our microbial library to be able to use a variety of carbon waste as a feedstock. We do have one particular one that is our launch feedstock. But for anyone who's looked into this space, a lot of your techno-economic is going to rely on your cost of feedstock. So that is going to be different if you're going to build a plant, say, in the US, as opposed to Brazil, as opposed to in Thailand. So it does call for that local understanding of what is the carbon waste stream that's available at low cost. So the engineered microbes was the second part of this. The third part is the way we think about a scale up is different. It's almost like forgetting everything that we know about biotech and building plants that look more like renewable natural gas, anaerobic digestion type plants, very much low capex in the way the bioreactors is designed and the overall system. Very much not what you think of pharma or high-end food type processing. And that's where we saw the opportunity, because a lot of times we need those things so that we could accommodate weak microbes. We're trying to make more robust microbes so that we could remove the burden from the capex for things like contamination, for example. So lowering the capex is extremely important in that equation, as much as finding low-cost feedstocks. So a few members of our team, that's their main focus. And we have our own process engineers and chemical engineers doing our own modeling and working with the EPC company, but focusing on that low capex is huge. And then the last part is the downstream process. This product that we're making does require, it's not extracellular, just like excretion. So we have to go through a process to extract the product. And we've created a pathway to not use solvents in the process. It's more of a modified mechanical process. This was a big deal for us. We even did a press release about it. So that downstream process is a huge part, also as lowering the cost. You keep hearing me talking about lowering the cost because this is the only way this is going to scale. We have to get there or have line of sight to how we're going to get there. And when you add up these four different equations, they all help. So when you look at SemVita compared to a lot of companies in this space, those things add up. And the way we think about scaling, we are going to build our first commercial plant, but we want to focus on these four things that I mentioned. What we don't want to focus on is how to do massive capital projects right now and how to secure the supply chain for a lot of the feedstocks and a lot of the end products, or trying to go into these verticals and become like a cosmetics company and a food company to then think that because we could do that and show people what's possible and market those products, that is going to create a version of the same platform issue that we already talked about, but on the back end. And people have done that before. Like if you look at Solazam, Amyris, which by the way, it's a huge, we're really, literally, this space is like riding on the shoulder of giants. There's so much learning in this space. A lot of things have changed. A lot of things haven't changed. So we want to make sure that if we make a mistake, it's not something that others have already learned the exact same way a few years ago. But those things were some of that differentiation in the way I see it.
I have a quick follow-up question. So you have a commercial plant that you're looking to launch, which is exciting. And just to understand, you guys are using waste carbon emissions. Is it from oil and gas?
No, not from oil and gas. We do have a pilot plant in Houston, which has been up and running since 2023, March. And we've used that to make gallon scale of the product to send for testing to our partners, because we want to make sure that what we make is a drop into their process, as opposed to some customized thing that we think is going to do better and then asking them to change their process. Zymergen tried that with the molecule for like foldable screens and stuff. And
yes,
that's very challenging to try to pull off. But the sources of the carbon waste, there's plenty actually of different sources, but sometimes there are the smaller amounts, like dairy farms, for example. Biodiesel industry has other streams that could be used. Agriculture, the same thing. So part of our team is almost this intersection with agribusiness, with biotech, which is already being done. When you look at renewable natural gas, for example, with anaerobic digesters. So what we're trying to do is to link what we're doing to that, instead of just being limited to CO2, because we do have a program around CO2. We're super excited about CO2. We have the right partners. We are going to do it. But it's also hard to scale because you need hydrogen next to the CO2. So is that green? If so, what's the cost? If it's not green, what's the emissions that come with it? So because of the challenge, we say, okay, let's scale the pathway from carbon waste to the end product. And then eventually we tag along both. So we could go from CO2 to organic intermediate, which we could feed into the same second reaction to make more product. So that gave us the flexibility, because I think it's all about flexibility, both in terms of your feedstock and in terms of the profile through which you could make your end product. This is why we decided to be a feedstock company, as opposed to try to go a step further down and become, say, a SAF company, for example, like, say, LanzaJet did off of LanzaTech. So the flexibility, I think, is going to be key to maneuver around a lot of the price changes in the coming years.
Yeah, I'm super fascinated by this because you talked about potential different waste streams. Agriculture brought up petroleum waste. You've talked about after you drill an oil well, you still have 50% of a product, and that could be a bioreactor or subsurface bioreactor. So I'm almost envisioning this distributed biological manufacturing part of your business where you're able to, I'll say containerize, because that's something I think a lot of people understand, containerize your process, take it to a place where there is this waste stream, and then turn it into a product that can be sold upstream to whoever the partner is. Is that approximately right, or am I getting that completely wrong?
That's the big vision, right? Even if you envision gold hydrogen, for example, if the plan goes as we think, they could produce hydrogen at a cost of less than $1 per kilogram with about the same carbon intensity as green hydrogen. So if you have that, we could couple that with CO2 and turn that into the organic intermediate. One part of this natural process is enabling the next. And who is to say that's not the best way? Because right now we have a version of that is based on chemical reactions and sometimes not very smooth handovers from one part of the industry to the other. The vision that we have is natural resource industry of the future. So that if you say oil and gas company, mining company, chemical company, we want them to think like a natural resource company instead of saying we're oil and gas. Because you have this exchange with nature, like what you said, Erum, earlier, it should not be extractive. It should be regenerative from the beginning in your design. If you're a mining company and you have a mine site, when you're done, no one should be even able to say that there was a mine here at some point, because you already have considered the recovery, the biodiversity, like everything else in it. Same in the oil and gas industry, same with the chemical industry. Like biochemistry replacing chemistry, one reaction at a time is the vision. Because the challenge that they have is it doesn't matter if you use green electricity or not, if you still require so much electricity to power a 1,000 degrees centigrade, 10,000 psi reaction. Whereas if you could replace that with ambient pressure and temperature and apply synthetic biology to make it fast, because that's been the challenge that they have. It's like, yeah, but it's not fast. Well, if you could do that and have it precise so that you don't have to spend as much on the downstream and separating all these co-products that you didn't want, why not? So we are at the early stages of that. And so we've already done this in pharma, in fragrance, and some of the higher end molecules, low volume. So this process of that starting to come into intermediates and then eventually maybe even to commodities is something that the industry should work towards. And that's where this comes in, with people from synthetic biology being more and more present and chemical companies and exploring what reaction makes sense to do now and then move on to the next.
Yeah, it's incredible. I mean, I love the natural resource company. I think that's a great vision to have. We need that. And it's been exciting to see how you guys are evolving and responding to what's going on in a variety of industries and being able to be nimble and agile and just listen and react. It's a great thing. And I want to say that when I was starting to learn more about SemVita, I'm like, okay, I'm trying to learn more. And I was like Googling things and I went to YouTube and I saw this video. It was your company retreat. And I think you were talking to your company. It was Hawaiian themed. You had a lei on. This is cool. I really felt like, I mean, is there companies so huge that they're having these retreats? And I'm just like, wait, this is really about Moji and his team, his leadership, creating a company of culture. And I want to start transitioning this conversation about how you approach building a company, especially in the biotech space. How many people are at your company, how you think about growing a team, just so we can understand what's going on in the mind of Moji.
Yeah, the video that you saw is from SemVita Day, as we call it. And the idea came because I was thinking, how come these big companies have these days where they talk about ideas and the future and they bring their network? And we're a startup. Why don't we do our version of that? I think also generally for events, the bar is set so low. We all have been to so many events. Everyone's dozing off. It's just boring. And so we try to think of ways to make it more fun. That's where the Hawaiian theme came in. It helped also that I'm a huge tiki fan, like cups and drinks and all that stuff. But it was a lot of fun. People came in with this expectation right off the bat. We give them a lei and we told them to wear Hawaiian shirts. So throughout the day, it was just a big party. And then the other thing that we do, we don't make that day actually about SemVita, even though it's called SemVita Day. It's more about sharing of ideas. We invite futurists, storytellers, basically to give people a chance to think bigger and think outside of the box. Last one, a futurist had a keynote about Leonardo da Vinci and how he did that. Like he used his background in art and science to come up with these ideas and his thinking process. And our scientists love that because they could relate in their own life. And I think we don't do enough of that. Conferences is very targeted and everyone just wants to pitch their company or something. So that's also part of the culture. We've gone through ups and downs ourselves as any company, but part of it was maneuvering this platform product situation was one of those. So we grew up to maybe about 85 people, but today SemVita is about 30. And then each of those two companies, I think maybe 15 people max. So it adds up to maybe about the same. But the other thing was at the beginning, for us as SemVita, we were trying to build more in-house, where IP was a much bigger issue. Processes were not clear yet. But throughout time, we've become a lot more targeted because if you fundraise now, you could actually afford more of A players. Your hiring strategy is more expanded. You could actually headhunt if you want to. So we've become a lot more targeted. That's why I think our future is going to be less people, but more targeted. The other thing I've learned is once you go from 30 people to the next layer, communication becomes a whole other world. And if don't have the right people to set up the right infrastructure, you out of a sudden start having all these communication issues. So being in this sweet spot, I think for the stage that we are right now is something that we're trying to protect and really challenge everyone when it comes to solving problems by just expanding the team as opposed to getting creative. And I've found also outsourcing now at this stage is the right time for us to explore more So all of that actually helps with culture because this office that I'm calling you right now, we're ending this lease and we're moving into the same space with everyone in the same space. Because
Nice.
we've always had different offices for the molecular biology and fermentation. And then there's the commercial team and pilot plant. So everyone is excited to be in the same place and working together more closely. But this space, last thing I would say is that it attracts really meaningful people because these are like really passionate scientists who want to help, who care about sustainability, and they're on a mission from the get-go. And whether if they come from a big company or from academia, there's a reason that they want to be in this exact space. As a matter of fact, sometimes we even had, because we're in Houston, someone who is doing cancer research even at MD Anderson, but they say, I want more tangible, something that I could see the result of in a few years. And that's why they see sustainability as an avenue to use their skills. So that's very helpful. And then on top of that, we have our core values, which we've really took time to curate. And this is something that we use in the interview process in the way that we incentivize and develop our own team throughout time. And this is something that we've been doing across the past 7 years.
Yeah, that's amazing. Just to cap that off, we're seeing this expansion. I love that you're seeing these people from MD Anderson, which are cancer researchers or hardcore, what we would consider to be traditional biotech in the healthcare space, moving into, let's just say, the climate space. But we're seeing this expansion of both biotech and climate tech industries. Do you have any advice for entrepreneurs that are looking either to enter these fields or people like you who are transitioning from a more traditional field into this? Any advice or words of wisdom you would share?
Well, I got really lucky that Tara just happened to be my sister and just like helped me. If it wasn't that, it would have been extremely difficult to try to understand the biotech landscape. So to that point, I think removing that limitation about where the solution is going to come from and keeping an open mind and realizing that you could have the right co-founder that knows that, you could hire people who were experts in that. So for me personally, I know common advice is that technical founders are the best, and there's a lot of truth to that. But I think it's about the combination and the vision to be able to start. And in this space specifically, people who come from a biotech background, they don't know about like mining industry. So how do you expect them to innovate in that space? And then those who are in those industries, they don't know about biotech. So you need the combination. And that's why personally, I love to go, and this could be one of those takeaways, is I love to go to events where I know nothing about. If different industry, different people, diverse groups expose yourself to different ideas. And that's where you'll be surprised. Sometimes a lot of ideas come from those combinations. The other thing that I did, and I encourage everyone to do this, is I mentioned this foresight study that we did at SemVita, and U of H has a course around that. I was wondering, how come futurists like Ray Kurzweil and others, they predict all these things and they're right? How do they do it? What's the framework that they use? Are they just super smart inventors, or is there more to this? And what I found was that there is a framework that is used, and it's called foresight. So I looked it up, and it turns out U of H had a foresight master's program, and they offer a course. It's a 1 week long class. So I went to that, and it was the best course I've ever taken. And on my table, I had people from NATO, from Epic Games, from academia, from snack companies. People were thinking about the future, but they want to build it systematically. I think it's a powerful tool to build a future scenario. And that's where a lot of these ideas will come in once you zoom in on a topic and area. So if you think about, okay, I want to do something in the space of libraries. I want to be an entrepreneur for libraries. If you do a foresight study for the future of libraries, I promise you're going to come up with like 5 amazing ideas that could be big companies in that space. So it's a bit of that framework. For us, we did the future of biosolutions in energy transition. I mentioned biological data storage and computing. I know it for a fact that that is going to be a huge category. And if you see it today, how much everyone's talking about the energy requirement for data storage and AI, and everyone is just trying to build more power plants.
Yeah.
Like, well, how could we use less energy in the first place? And oh, did you know how much efficient DNA is? And if you go beyond that with peptides and how much data we could store, and then there's the computing part, like our brain. So how could we learn from next-gen ways of doing the same thing without needing as much energy requirement? So for someone who wants to look at this space, is have to put yourself in that future vision and explore what ideas may surprise you.
Yeah. That's something like Carl and I love in some of the episodes. We really take it far into the future. We just love speculating, but having a framework to really think it through. I mean, I would definitely want to check out this foresight. We'll put a link in the show notes so other entrepreneurs can check it out. But that's incredible. What's it like working with your sister?
I joke when people ask me that it's much better than working with your spouse. I do not recommend that. That does introduce a lot of risk also for the company. But for my sister, it's been amazing. And part of it is because when you have a co-founder, the number one requirement is you need to have 100% absolute trust in each other. And the trust comes from knowing that no matter what is going on, the other person has good intentions. And when that happens, it means that, oh, well, everything else is about communication and having a process for decision making. So it's been amazing to do this with Tara. I would say the caveat is, and we got there and we fixed it, if you could lose the sibling relationship because you're always just like talking about work and at work or outside of work, and it changes. And for us, it's even weirder because we talk Farsi is our mother language, but then sometimes at home we're just talking English and talking about work, and that's a trigger. It's like we should not be talking in English about work at home. So let's switch back to Farsi. So we had to set up a system. If you go one weekend out of town, we make it a point that this is not about work. And what's been surprising, actually, we come back with even more ideas for SemVita when we're together, but they don't think about SemVita for a day. But no, it's been great, I think, in some weird way, because there is a legacy of family-owned businesses, but they're more like, I don't know, meat packing or something.
Yeah.
And to have a high-tech biotech startup, but I think that the combination of our skills in that she's over the science and technology on the commercialization side, it allows us to not have overlaps in a way that creates undue friction.
Yeah. Yeah. I mean, I would love to work with my sister. I also have two brothers, and I don't know about trusting them, but my sister
That's
is
what everyone
amazing.
says. Yeah.
Yeah, brothers. No, but that's a beautiful thing. And I bet your parents and your family are just very proud that you guys have come together and built this big company. So congratulations
Thank
to
you.
you and your family. But yeah, this is incredible. I know you guys are working on your first commercial plant. We're really excited to learn more about that. If there's any investors listening, Moji's right here. We'll put his contact information. Sounds like a great opportunity. But thank you so much, Moji. Thank you so much for taking the time of your busy, busy day to come and talk to us about what you're doing. I think it's be really helpful for our audience. And we'll have to have you back on.
Absolutely.
My pleasure. Yeah, anytime. Thank you.
Thank you. What did you think of our interview with Moji?
He is the entrepreneur's entrepreneur. What a great conversation. I just love the fact that he talked through this push and pull that I think a lot of entrepreneurs face, especially in a world where we have a lot of technology. There's a lot of problems that can be addressed by a platform technology, but they can also be addressed through specific products. So for Moji being in that position to understand and deal with the platform product situation, how SemVita took the approach was a great thing. And I hope we do have some entrepreneurs listening. We have future entrepreneurs listening, people that work at corporates that need to rethink how they approach how they're delivering value into the market. This was a great conversation for them to get ahead of it. Like, hey, look, do we need to spin out companies? Let's focus on creating this platform rather than just creating specific products. Let other people just focus on that, because that is a whole business in and of itself. And I really enjoyed that conversation. What about you? What did you think of that episode?
I'm going to riff on what you just said, because I think it takes a very special kind of entrepreneur to realize you can't do it all, and that actually you can accomplish more if you do spin out parts of your company, or if you have a technology developed and it doesn't make sense for you to keep it in-house, to spin it out and have someone else run that, maybe not even as another division, but just as a whole other company, because it can become a distraction. So I really admire Moji and his sister for doing that. And the fact that he talked about it, I think, is a lesson for any of the entrepreneurs that are listening to this podcast today. The other thing is that I was super blown away by some of the applications, and this idea of using oil wells as bioreactors is something that I will take with me to the grave, because it just made me think mines as bioreactors. Should we be talking to Rio Tinto about how we can start turning these mines into huge bioreactors? What else can you do with empty oil wells? You've got some oil in there. You've got some gas that's being generated by this oil. What kind of microbes can you throw in there to create useful products? To me, that was mind blowing. And I think that being able to do that also harness it will be something that we do as we move off planet. We know that there's other places on the planet and there's things under the surfaces of all these planets, and being able to use microbes to turn those gases or those emissions into useful products. I mean, that's our future in space. So Moji blew me away, and I can't wait to have him on again in a few months just to hear the progress that they're making.
Yeah, they have a new commercial plant coming online. So we'll be paying attention to that. We love when we hear stories of scaling up in our industry. So we're going to see how that plays out. We do want to wish Moji and the SemVita team all the best with that. We met some of their team members at Biotech, and they're very incredible. I think that has to do a lot of their Southern charm because they're based out of Texas. And you can definitely sense that they have such a good culture and camaraderie. And that is attributed to the way that Moji and Tara, his sister, how they lead this company. The culture has been permeated through the people that are there. And it would be really cool to be around them and just see a day in the life of working at SemVita is like. People are very motivated because they are creating technology that is sustainable, that is helpful. It's a good vibe. And they have great leadership. So Moji was talking about this foresight framework, which I think we need to dig into more. It just sounds like a great way of thinking of the future. I know we always riff like from earlier on the intro and even the last sentences you said, we always think about how do we get into space? What do we do? We're always just thinking about that. But to have a framework to think about it more strategically sounds very interesting.
I know that certain companies like Amy Webb's companies have many of those frameworks available. And Moji did say that he spent time and took a course in foresight strategy. It was very smart. There is so much change happening, and being able to strategically think of what the possibilities are for a technology. We have a lot of fun doing it. The tools that the foresight companies have available make it easier. And I think we should maybe do a whole episode on foresight and get someone on here to talk to us about it so we can learn more directly from someone who does it.
Mm-hmm. Yep. So great episode. It's a company that we will have on again. It's great to see them in these early days, how they're growing, how they're making decisions. Major congratulations and thanks to Moji, Tara, and the team at SemVita.
All right. Well, I think that's the pod.
Yes, please take a look at all the references in the show notes. We love when you guys reach out to us. We've been reading your comments. Thank you for all of the ratings. We get 5 stars. We've been ranking high on Life Science Podcasts. So hello, you see us there.
Thank you.
Thank you so much for listening. We really appreciate it. We're excited to engage with our community. We'll see you at events and be in touch. Stay in touch with us.
That's the pod.